Hi guys, I want to show you one example for an enthalpy calculation. So here's our example problem. I'm going to do the same one in class, but in case you need to see it again, this is just going to be the exact one that we're doing. You can just watch as many times as you need to. So our example problem is to calculate the enthalpy of the following chemical reactions. So we've got 2 C2H2 plus 5O2 makes 4 CO2 plus 2 H2O. Let's go into present mode. Maybe that will work. And I want to write. Okay, so we have several steps here that we want to do. So that's blue. How do I change color? Red? Yeah. Our first step is going to be draw Lewis structures for every single one of these molecules. So we're going to draw structures. Our second step is going to be count the number of bonds of each type. Our third step is going to be multiply the bonds by the energy it takes to form each of those bonds. So multiply count by the bond energy. And then our fourth step is going to make sure that we are subtracting products from reactants. So those are our steps. I'm going to move me. Now I'll just go hang out here in the corner. Okay, cool. So first thing we want to do is draw structures. So C2H2. If you don't know what a Lewis structure looks like, you could try and draw it yourself. You can look it up. You can ask me. There's lots of ways to figure it out. I drew this one, and then I went and looked it up just to double check it, and I was wrong. So definitely worth looking into. So it's actually going to be the C's are triple bonded to each other. And then we're going to have a hydrogen on either side. And I'm going to have 2 of those. So another C carbon triple bonded to itself, and then a hydrogen single bonded to each one on either side. I forgot to do a triple bond. I did a double bond. I should have done triple. This is why you can double check. And then I have 5 oxygens. So oxygen double bonds with oxygen, and we need 5 of those. So I'm going to draw 5. Okay. Then we have carbon dioxide. So carbon, oxygen, double bond. And we need 4 of those. Carbon, oxygen. And then we need H2O, so O, 2 H's. We need 2 of those. Okay, so that's all of my Lewis structures. You don't have to draw necessarily all of every single one. You could draw one of each kind and just make sure that you multiply by the number of molecules you have. But since this is our first example, I'm going to be extra thorough and just draw it. So that's step 1, draw structures. Ding. Now we're going to count the bonds of each type. So I have 1, 2 carbon triple bonds to another carbon. And then I have 4, 2 times 2 is 4, of the carbon hydrogen single bonds. I have 1, 2, 3, 4. So I have 4 carbon hydrogens. And then I'm going to add up now, moving on to my oxygens. I have 5 oxygen, oxygen, double bonds. And that's the end of my reactants. So I'm going to actually move on and think about the 4th step, and I'm going to start subtracting now. So I'm going to start subtracting my products. So now I've got 4 carbon dioxides, and that is going to be 8 carbon, oxygen, double bonds. Okay? Did I do that right? Oh dear, I didn't. Okay. I have it on paper too, and I think I made a mistake now that I'm looking at it. Got to be careful, guys. And then we got to do our hydrogens. It's the same type of bond, so we just need 1, 2, 3, 4 OH bonds. Okay, so now we've counted each type, and we already started our subtraction process, so we'll like check it anyway. Now we got to plug in our numbers. I have the numbers next to me already. You look them up in the table, and I'll show you what that table looks like just as a reminder so you know you're looking at the right table. It turns out that there are lots of different values from different groups measuring these bond energies. So I aggregated one table for us to use in class. Make sure you're using that table so that our numbers match. Okay, so I'm going to start plugging in numbers. So instead of the carbon triple bond to carbon, that is 839 kilojoules per mole. So kilojoules is the 839 per mole. So we multiply it by 2 because we have 2 moles of it. Plus 4 carbon hydrogen, that is 413 kilojoules per mole. Plus 5 oxygen-oxygen double bonds, which is 495. Minus 8 of our carbon double bond oxygen, which is a special one for carbon dioxide, and it's 799. And then minus 4 of our OHs. Okay, oops. I already forgot that we were plugging in numbers. I'm doing this after school, so my brain is not exactly in the right place, but we do our best. 467. Okay, and I punched this all in the calculator in one line, so I'm going to show you guys how to plug this in. So we're going to escape, and hopefully, yep, it's gone. That's okay. I'm going to pull up my calculator, and I'm just going to plug in, just leave it there, plug in exactly what I had. So I'm just going to do 2. I think I have to actually do it 2 parentheses 839 in parentheses plus 4 parentheses 413 plus 5 times 495. And then I got to remember to start subtracting now because I'm on my products. So minus, it was 8 times 799 minus 4 times 467 in parentheses and enter. And I've got 2,455 kilojoules of energy, and it's negative, which means it's released, so it's exothermic. If we take a look at our equation, you'll notice that, hey, it's a fuel, then an oxygen, then carbon dioxide, water. This is a combustion problem, so yeah, we should have it be a big number. So it was 2455, so let's go ahead and write that down. Negative, I don't know why I'm doing this on here. This is literally what this is for. Negative 2455 kilojoules. Ding, ding. And that's how you do it. If you go through the steps and you are really, really careful, you can do it, but you have to be very precise with the way you count it. Okay? Hopefully this has been helpful, you guys. I'm going to end it here if it lets me.